String optimizations. In this chapter, we'll look at various rules that can be applied to optimize your application when dealing with strings. Avoid creating string using new operator. That is rule number 1. Rule number 2 deals with concatenation. We'll take a look at what this means. Rule number 3 is defer the string creation until the point when it is required. So let's look at rule number 1, which is saying avoid new operator. Instead of using new operator, what we can do is we can use a string literal. Some key features about strings are: first, when a string is needed, it will check if the specified literal is present in an area called string constant pool. This is also called SCP. If yes, it will return the object from the SCP, else it will try to create a new one in the SCP and return it. Second, string class is immutable. Hence, it can safely be used in multi-threaded application. But wait a sec. If used in multi-threaded application, wouldn't it result in race condition between two threads if both the threads are trying to modify the same string? Well, string being an immutable class will return a new string when it is modified. Hence, there is never a resource contention. Here is how our heap looks like. So within the heap, there is an area called string constant pool, or the SCP. Any strings that are created using literals or intern will land up in SCP area. In the first case, we are creating string S1 and we are using literal. So we are having double quotes, John, double quotes. So you can see that S1 is a variable and it is pointing to an string which in the SCP area. The name of the string is John. In the second case, we are having variable S2 of type string. And since we are using literal, it is going to check if John is already existing in the SCP. In this case, that is true. Hence, instead of creating a new string, it is going to refer to the same string. In the third case, we are having another variable S3 of type string. But in this case, we are using new operator to create the string. Though the content of the string is same, like John, but it is going to create a new string in the heap. It is not going to refer to SCP. The fourth case, we are having S4 of type string and we are assigning S3.intern. So since we are using the intern, it will again point to the same string from the SCP area. The rule says that instead of using the new operator, we can rely on either using literals or we can rely on the intern method of string class to refer to the string in the SCP area, so that pool of strings in the SCP area can be reused. So when dealing with application that has low memory and or involve frequent creation of strings, this rule can be adopted to boost the performance. In this demo, we are having string demo 1 class. We are having a static final which is set to 1 million. So this is the number of strings to be created. We have one method which is using new operator to create a string, and we have another method which is trying to create a string, or rather reuse a string, but you can see it is not using the new operator, it is just using the string literal test. We have a public static main method. In this case, we are creating an object of string demo and using get execution time. So this will use reflection to invoke this particular method, create string using new, and we will capture the duration it takes to execute that particular method and we'll kind of log it. So same thing we are doing with the second method, which is create string without new. If you try to run this, you can compare the results. So you can see in the first case it is taking 7 milliseconds. In the second case it is using 1 millisecond. So there's a lot of difference. And definitely, I mean, here we are having 1 million iterations. So 1 million times we are trying to create the new string. In the second case, it's just having one copy. So hence it's going to be faster. Let's look at string optimization in regards to concatenation. So this rule says that we can use StringBuilder instead of using a plus operator for concatenation. Let's understand this with two examples. In the first case, we are trying to concat the original string with certain piece of information. So in this case, we are doing symbol plus price on plus current date. So when we use the plus operator, what is going to happen is, since it is going to cause an modification of this particular string, it will result in a new string being created. And that new string, again, we are using a plus operator, and we are appending current date, and this goes on. So eventually we'll be getting a string which is a concatenation of all these strings. In the second case, we have the same functionality, but instead of using the plus operator, we are using a string builder. So in this case, first we are creating a string builder object, and we are allocating an approximate size, in this case 200 characters. Then we are calling sb.append, and we are passing the symbol. So this is going to append the content of symbol to SB, and eventually we will be calling dot append on that. So since string builder is not immutable, it is still returning the same object. So in this case, sb.append is actually returning string builder, and on which we are again invoking dot append. And this goes on. So eventually, once we execute this particular step, string builder is going to have the concatenation of all these strings. And then in order to convert that into a string, we are using sb.toString. So in this case, the string builder version is going to perform better because there are no new strings being created. Whereas in this case, there are multiple temporary strings that are created every time it uses a plus operator. Also, in the case of string builder, since the number of strings being created is less, there will be a less GC overhead. Hence, the overall performance will be better. Here is an example of string concat demo. So our class name is string concat demo 2a. The number of strings to be created is 1 million. We have two static methods, concat using plus and concat using string builder. You can see in first case we are using the plus operator to concat each of the strings, and in second case we are using a string builder. We are creating a string builder which is of size 200, and then we are calling dot append on each one of them. Now let's try to run this and see the result. So in first case it is taking 386 milliseconds, whereas in second case it is using 274 milliseconds. So naturally the string builder is performing better as compared to using plus operator. Let's look at another rule with respect to concatenation. Use string builder in single-threaded application, whereas use StringBuffer in multi-threaded application. StringBuffer incorporates locking, hence will have less performance as compared to string builder. So in case of single-threaded environment, make sure that we are using string builder as against StringBuffer. Let's look at string optimization with respect to string creation. This rule states that we should defer string creation until a point when it is required. So it simply means be lazy in trying to evaluate or create the string. Let's take a look at demo example in this regard. So in this use case, we have an order processing application in which we are trying to process the order. So you can see we are trying to create a dummy order, create a dummy error, and then try to submit the order. So all these things are like mocked. So they are not really adding value. They're just returning string, or in some case doing really nothing. In this case, submit order is not doing anything. Now in the first method, So we are having process order using non-lazy method. So in this case, what we have done here is we are trying to create an order and then trying to submit an order. In between, we have two statements. One is logger.debug, and we are having, if the order is submitted, then we are having logger.info. Now, typically, there's going to be a lot of debug statement that developer will be putting throughout the application just for debugging better. In most cases, the debug statements are not required in the production environment. Now, if you closely look at this, when we invoke logger.debug, it is going to construct this particular string. So you can see that we have order detail plus actual order details. So it is going to construct the string and then invoke logger.debug with that particular string. We don't expect debug statements to be there in production. So there's no point in creating. A better approach is to do it this way. So in this second example, which is process order underscore lazy, we are checking if debug is enabled. Only in that case, we are calling logger.debug. So in this case, in production environment, we know that debug most of the time will not be enabled. Hence, this will never get executed. Hence, there is no overhead of creation of this thing. So this is an optimization that we can consider if there are a lot of debugs and then our performance is getting affected because of that. So we can really defer the string creation until when it is required. So that concludes our string optimization chapter.